back again with another video on Leetcode. So this is like today's contest, weekly contest 326. So in this contest, like there are 4 questions asked, one easy and 3 medium. So during the contest, I was able to solve these 2 questions, and after that I have some work, so I left these 2 questions. But when the contest was over, I tried to solve these 2 questions, and I have solved it. So just we will go through each question one by one. So let's go to the first question. So this is the first question: count the digits that divide a number. So this was a very easy question, I should say. So basically in this question, you have a given integer number, and then you just need to count that from that integer number, like the digits of that integer number are able to divide that number or not. Okay, so you just need to count that number. So basically here you can see like you have a given number, and then I just taken a variable count equal to 0, and then just assigned the num integer to a variable p, and then you can just for taking out a digit from a number, you just need to uh, take the remainder from that number. So here that k represents the digit, and here you just like in every iteration you need to divide that number, divide the p by 10, so that next you can take out the next digit of that number. Okay, and here like you just checking whether that k can divide num or not. So basically in that you can count, and like this is already I have submitted during the contest. So hope you have understand this question. Let's move to the next question. Okay, so yeah, this is second question of the today's contest. So given an array of positive integers, nums, return the number of distinct prime factors in the product of the elements of nums. So basically you have a given array, and you just need to uh, count the number of prime factors in the like a number made by product of all these numbers which are present in that array. So basically here you can see from the example, so this you have to do. So in this question my first intuition was to take the product of all the number, and then count the number of prime numbers that are factors of these. So that was my intuition. But yeah, if you are going to take the product of all the integer numbers in that array, then it will go out of range of that long also. So that I was done first, and in that I lost my 5 minutes. Then I thought to take the prime factors of each number individually and store into a set, and you know that the set stores only unique numbers. So from here you can just get the unique factors of the number, and then you can just return the size of this unordered set. Okay, so here one thing is that if you use unordered map in case of unordered set, then the code will run faster. That I have checked. Like previously I submitted with unordered map, so it was faster than the unordered set. Okay, so basically the logic here, you just need to store all the prime factors of each number in the unordered set, and like unordered set will store the unique numbers only. So at the end you just need to return the size of this. So for this, like I will just start from I equal to 0. So basically one by one you can just using the loop, for loop, you can just assign c each number of that nums vector, and then using this using this function you can just count the number of prime factors have that number. So basically here, like, to if that number is divisible by 2, you just need to divide it until it get undivisible by 2. Okay, so here it is like that, and then you can just start from 3. Okay, so you can start with 3, then after that you just need to uh, take plus 2, because if you take plus 1, then that become even number, and even number, like, is a not a prime number. So that's why here it is plus 2. Okay, the second thing, maybe you will think if 9 will come in this. So basically when 9 will come, it will not divide C, because already I have taken 3 which divide 9. So basically that 3 will divide the number uh, as many times as it will become undivisible by 3. So this is the logic, and that many times I will use to insert this into that set. But yeah, ki set has unique numbers, so basically like that. And then at the end, if this C is greater than 2, means that you have a prime number, so then you need to insert that also. So this is the code here, and this also already accepted in the this Leetcode contest. So let's move to the third question. So basically this is the third question. Partition a string into substrings with values at most k. So you are given a string S consisting of digits from 1 to 9 and an integer k. So a partition of string S is called good if each digit of S is exactly present in one substring, and the value of each substring is less than or equal to k. So then you have to return the minimum number of substrings in a good partition of S. If no good partition of S exists, then return -1. So this is the question, and here are some notes. The value of a string is its result when interpreted as integer. Okay, and a substring is a contiguous sequence of characters within a string. Okay, so hope the note is clear, and then you can see here some examples. Okay, so here the my logic is that you just need to take an integer from the back side, and you need to take continuously the next integer until it becomes greater than your k value. Okay, and if it becomes greater than your k value, then you just need to leave the digit as it is, and start from fresh by taking that digit. Okay, so here you can see, like, we will take 2, and 2 is smaller than 60, so you can take second number also, 6. But while I take 6, it become greater than 60, so then 2 become a substring. Okay, and then I will start again from 6. So I take 6, 6 is smaller than 60, so I continuously take another digit, so I will take 4 also. So here, while taking 4, I will just multiply it by 10 and add it to 6, so that it become 46. So that is also lesser than 60. So again I will take 5, and this time I will multiply 5 with 100. Okay, so the it will become 546, but it is greater than that, so I will leave 5 and make 46 another substring, and I will start freshly from 5. So similarly for the other 2 digits. Okay, so hope you understand the logic. So same logic I implemented here. So just count for counting the number of substrings, and int so that I can start from the end of the string. Okay, then here is long t equal to 10, so that whenever I take the second digit in a continuous manner, I need to multiply with t, and again third, then t becomes 100, like that. So for that I taken t, and long b is for storing that number. Okay, so this is the logic and code. So then I will check if here it is character 0. So like if you subtract character 0 from the characters, then you will get the integer value. Okay, so this basically subtract the ASCII value of each character, and in that, like you will get the original integral value of that element present in that string. Okay, so basically if that b is greater than k, then you have to just return -1, because you can't do a partition, because a single uh, integer, like a single element, is greater than k, so you can't make a good partition, so you just need to return -1. If it is not like that, then you just have to continuously take other digits, subsequent digit. So in that case you just need to take like b equal to b plus t into, like that, t is multiplied, so that it will become like I have given in the example, it will multiplied with t and it will become 40. Like in case of here, you can say, like first you take 6 and then you taken 4, so 4 will become 40 and plus add 6, so this will store that, so it will become like that, so 46. So then you need to check b is greater than k or not. If it is greater than, then you just need to take count plus plus and I plus plus, because I have subtracted 1 from I. Okay, so for recovering that, you just need to plus II and then break, so that you can start again from fresh. And you just, if it is keep on going, then you need to increase t by multiplying it by 10 every time, so that like a new digit you will get it in, it is 10 times more than the last digit. Okay, so basically this is the logic here. And then at the end, you just need to check whether b is smaller than or equal to k, and I is smaller than 0. So then you need to take the count plus plus, because that will be the last substring, and the loop is already over, and we have not counted because it is inside this. So for counting that, you just need to put this last one, and then you just need to return this count. So this is the whole code for this question, and hope you have understand. Let's move to the last question of this contest. So this is the last question of the today's contest. So this is given to positive integers left and right. Find the two numbers num1 and num2 such that num1 and num2 lie in between left and right, including left and right, and num1 should be smaller than num2, and num1 and num2 both should be a prime number, and num2 minus num1 should be as minimum as possible. And if you are getting more than one pairs of this kind of number, num1 and num2, then you should have to print that pair which has num1 smallest num1. Okay, so this is the question here, and you can see from the example like 10 and 19. So basically 11 and 13, these are the prime numbers which have like the smallest difference, and 11 is smallest, so you have to print 11 13. Otherwise there is another number 17 and 19, but 17 is greater than 11, so we have to print 11 only. 11 and 13. Okay, so this is the question, and from this question you can build one logic that you have to start from left and go up till right, and you just need to take all the prime numbers, and then you just need to check which prime number pair has the least difference. And then if you find the same difference in more than one pairs, then you just need to check which one has the smallest num1. Okay, so with this logic I am going to apply this code. So basically you have to check if left equal to right, then you can't have any pair, so you just need to return -1 as it is written in the question. Okay, and then if the left is 1, then you have to just increase by 1, because the prime numbers will start from 2. Okay, and in my code it was taking 1 as prime number, so that's why I increased it if it is like that. So basically then you have to start from, like, I taken one integer start for left and end for right, and there are two integers previous and one is difference and one is mini. So basically previous is storing for the previous prime number, and st will store the current prime number. Okay, so and then this difference will be the difference between our current and previous prime number, and mini will store the minimum difference of the current and the previous prime number. Okay, so this is the logic here, and so we will have a vector answer, and it will have -1 and then we will move through from starting from st and go to end. Okay, then I have taken int I equal to 2 and int p equal to 0. So basically I taken p for checking whether the number that is in st is a prime or not. Okay, if it is not a prime, then I will make p equal to 1. If it is a prime, then it will be 0 only. So this is the logic, and then I have started int I equal to 2, and I will go up till under root of st. Okay, so if a number divides, then it will not be a prime number, and if it is not able to divide, then it will be a prime number. So basically, so then we will go if it is a prime number, then we will check if previous is 0 or not. So basically if it is 0, then you have to first assign previous equal to st, and then you have to again go through this, and then when you find next prime number, then you have to take the difference, and if the mini is greater than the difference, then you make the mini equal to difference, and then you have to store answer 0 equal to previous and answer 1 equal to st, and then you have to just increase st one by one, and by this you will be storing the answer in the answer vector, answer 0 previous and answer 1 equal to st. So this is the code for this question, and hope you have understand this, and this is all for today's video, and hope you have solved all the 4 questions of the Leetcode today's contest. And so this is all, and please share, subscribe my channel. So thank you for watching my video. Thank you.